Good morning, good afternoon, good evening. Today I'll be making this Bendy Text Effect. Believe it or not, for the animation in the background, the only thing I'm doing manually is keyframing the location of the text. The deformation of the text is automatically created by the geometry node setup, giving it a feel of text responding to physical inertia. This is a pretty good effect if you want to add a little bit of cartoonish feel to the text motion, and to be honest, the node setup is quite simple. So, let's get into it. Alright, as soon as we get into Blender, let's hop right into Geometry Nodes Layout. H to select everything, X to delete, Shift A, and first add an empty plane. This plane axis will act as a controller object for the text. Next, we'll add a mesh plane. Using numpad 7 and 5, go into top orthographic view. Since we won't be using the spreadsheet, we will get some more real estate like this. Click on new. Use this pin to pin the geometry nodes map. Delete the group input. Insert a string input instead. Put in something like test in here and pass it through strings to curve and up like so. Okay. We'll just fill the curve so it's easier to see. And for this effect, what we will be doing, or what's going to happen, is whenever the text moves, like so, say for example for this T, the T is going to deform like this, as if it's being overtaken by inertia. And yeah, everything's gonna deform, so it's gonna look a little bit more dynamic. So to do this, what we need is to first figure out what the speed is, and also calculate the influence factor based on the distance of delta y, like so. Okay. So let's start doing that. And like I said in the beginning, this empty will serve as a controller object, so we'll drag it right in. And now we'll add a simulation zone, pull out a line from location and plug it into this empty socket right here. Then we'll also plug it into this location. And finally, out of location, we'll pull out a vector mass. Change it to subtract, and subtract the simulation output location into here. Next, we'll pull out a divide, vector mass divide, and divide it by delta time, like so. Okay. From this divide output, we'll plug it into simulation output, like right here, into empty socket. Click on simulation output, go to the node tab and rename this to velocity. Okay, so now we get the velocity coming out of here. All right, so since right now the empty and the text is not linked, let's link it together by using a transform geometry. Pull out a line from location, put it into translation. Now, when the empty moves, the text also moves. Next, we can check if we're actually getting the speed. So from fill curve output and also velocity, we'll pull out a viewer like so. And with the animation running, if we were to move the empty, you can see the color changes, and when it stops, you can see it turns to black. So we can see that we are actually getting the velocity. Okay. All right, so velocity part is done. Next, we'll calculate the influence factor for each point, so we can deform it. So what's going to happen is we're going to have a base point, which is going to be the instance location or instance position. And for each point position, we're gonna calculate the distance, or actually the y distance, right? So the first thing we need to do is store named attribute of the instance location. So change this to vector and instance, call it pod0, and first let's store the original instance position, like so. Next, we'll resample, so we'll have more points to play with. Set it to length and 0.01 for the length. Then we'll realize instance, like so. Okay. So now we got all these points, and we want to get the distance from the instance location. So first thing we'll do is grab a point position, and using named attribute, and we'll use a pod0, and by subtracting pod0 from position, the point position, we can get the distance. Now we only need the y part, so we'll use a separate xyz, and we get the y, right? So in order to deform the text, what we'll need to do is set position for each point. And the way we're going to set its position is by multiplying this vector. So I'm going to use the scale, vector mass scale, and multiplying by this y right here, and plug it into offset. Okay. So now if I were to run the animation and move the empty, you can see the text is now deforming. But there's two problems with it. As you can see, there's too much movement, and the direction that it's tilting to is the wrong direction. So the first thing is we want to reverse the direction. So using -1 scale, I'm going to plug it right back into here. So now it's reversed. Next, add a mass node, change it to multiply, plug in between separate XYZ and scale, like so. So now we can control the influence by this value right here. Okay. So if I were to move it, you can see it's less drastic, and also it's tilting the right way. We also want to make it bend, so I'm going to add another mass node, change this to power, change the exponent value to 2, and I'm going to plug it into here between separate and multiply. And now if I were to move the empty around, you can see the text actually bending, right? So it looks more flexible. All right, cool. So I won't be making any materials today, so actually the geometry node part is done. We'll move on to making some animation. So let's go back to frame 1. I'm gonna pull out a graph editor right here. Okay. So frame 1, what I'm gonna do is move the empty 2 units in the y direction, so it kind of looks like it's hovering above. I'm gonna keyframe the location, then shift the timeline over to about 50 frame, move the empty over here, and keyframe the location. Next, I'm going to go into the graph editor. I'm choosing the Y location, selecting the first frame location, and I'm going to change the keyframe interpolation type to bounce, like so. Next, for the X location, I'm going to select the same frame 1, change the interpolation to quadratic, and also easing to ease out. Okay, so the graph looks kind of like that. Now if I go back to frame 1 and play the animation, you can see the text bouncing off the floor and deforming, like it's actually stretching because of falling part and shrinking because when it bounces, it shrinks. Okay. So if I were to continue doing some animation, I can say, for example, insert another keyframe here and insert another keyframe here. Move this down so it looks like the text is sliding over to the left after it bounces, like so. Okay. All right. We're pretty much done. So let's go over what we just made. Basically, there's two parts to it. The speed calculation, velocity calculation part, and the influence calculation part right here. And it's a pretty simple, compact node tree. It's pretty fun to make, right? Yeah, making the text move a little bit more dynamically, and it's kind of nice. So hope you guys enjoyed it. See you next time.